Assalamu alaikum, dear students. I hope that everyone is doing well. We have to continue with Unit 5, Sets and Functions, and for today the topic is binary relation. Dear students, we have to go with exercise 5.5, but before proceeding towards the exercise, let's have a revision of the topic binary relation. If A and B are two non-empty sets, then a subset R subset A cross B is called binary relation from set A into set B, because there exists some relationship between the first and second element of each ordered pair in R. We can better understand this with the help of example. Suppose we have set A which has the elements 2 and 3 and set B contains the elements 4 and 6. Then we have to form a relation R from A to B such that X relate Y or X relation Y such that Y is double of X. So we have to establish a relation here in this example where Y is double of X. So we cannot make this relation until and unless we have the Cartesian product, because the Cartesian product contains all the relations between the elements of these two sets, whereas the relation contains the specific relation which is given here. So first of all, let's find the Cartesian product, that 2 with 4, 2 with 6, 3 with 4 and 3 with 6. Now we will establish a relation where Y is double of X. So we can see here that 4 is double of X, whereas 6 is not double of 2 but 6 is double of 3. So we have the relation or the ordered pairs in the relation 2 and 4, 3 and 6. So this is the specific relation known as binary relation. We have domain of the relation. The domain of the relation is the set consisting of all the first elements of each ordered pair in the relation. For instance, this is the relation, so the first element or the first element of ordered pairs are 2 and 3, so these will be the domain. Whereas the range of the relation is the set consisting of all the second elements of each ordered pair in the relation. We can see here 4 and 6 are the range, the second element of the ordered pair. We have here exercise 5.1. Question number 1. If set L has the elements A, B and C and set M has the elements 3 and 4, then find two binary relations of L into M and M cross L. We are going to find two binary relations. Remember one thing here, that there is means the identification is not given, that what type of relation means you have to find the specific relation, or the identification is not given. So it's up to us, we can find any subset or we can find any relation between the elements. So here first of all, let's find L cross M. L cross M or L into M is here. Set L should be written first and set M should be written later. So first of all, we have to find the Cartesian product, then we can find the binary relation. So n can be means we can relate A with 3, A with 4, then B with 3, then B with 4, C with 3 and C with 4. This is the Cartesian product. Now we are going to find two binary relation. So here it is written R1 for the first binary relation and R2 for the second binary relation. So as I told you that there the identification is not given, that what type of relation should be between the elements. So you can hold or you can pick any of the ordered pairs here, any subset of this set. Subset is that set where the elements of this set should be present in the L into M. So then this set will be the subset of this. As you can see, A3 is here, B and 3 is also here, so C and 3 is also here. So we can say that R is the subset of L into M. So I have made the relation A with 3, B with 3 and C with 3. You can take any of the relation of any of the ordered pairs from L into M. It will doesn't affect, or it doesn't matter. Similarly, R means second relation, I have taken A with 4, B with 4 and C with 4. It is not necessary that you must take 3 ordered pairs. You can take 2 ordered pairs, you can take 4, you can take 5, or you can take 1. but you have to take but you have to make sure that this should be the subset of this. You cannot pick any other element from any other set. All these elements should be in the L into M. Question number 2 is, if y is equal to minus 2, 1 and 2, then make two binary relations for y cross y. Also find their domain and range. So first of all, here we are going to find the Cartesian product, then we are going to find two binary relations. Again, here there is means the identification of that relation is not given, so you can make any subset as binary relation. So set y, and again cross means multiplication sign, again set y. So minus 2 with 2, minus 2 with 1, minus 2 with 2, then 1 with minus 2, 1 with 1 and 1 with 2, then 2 with minus 2, 2 with 1 and 2 with 2. This is the Cartesian product. Now we are going to make the binary relation R1, the first binary relation. Now you can take any of the subset, means any of the ordered pairs, and you can name it as relation 1. I have taken here minus 2 with minus 2, 2 with minus 2 and 1 with minus 2. You are not going to take the same relation. You can make any relation, means you can take these two, you can take any of the ordered pairs and you can name it as R1. Now we are going to find the domain of this. So minus 2, 2 and 1 will be the domain, the first element of the ordered pairs, whereas the range will be the second element. So the second elements are minus 2, minus 2, minus 2. So you are not going to write minus 2 3 times, because instead the elements are not repeated. If we write it one time, that will fulfill the purpose. So just write it once. Minus 2 is the range. Next relation, I have taken 1, 1 and 2, 2. You can change it and you can make any subsets here as relation 2. So the domain is 1 and 2, and 1 and 2 are the range as well. Okay, here we have question number 3. If set L has the elements A, B and C and set M has the elements D, E, F, G, then find two binary relations. We have again here means we have to find the two binary relations, and we this question contains 3 parts. Just first part is done here, and these 2 parts are similar to this, so you can do it yourself. You can do them yourself. So L into L, set L is written, then again multiplication sign and set L. So A with A with B, A with C, then B with A, B with B, B with C, C with A, C with B and C with C. So 3 and 3 will be 9, so there are 9 ordered pairs in L cross L. We are going to make two binary relation. This is R1, so you can take any means any subset can be, any subset of this set can be as relation. So I have taken here AA, BB and CC. You can change it yourself. Next relation, I have taken AC and BC. You can increase the number of ordered pairs. You can take 4 ordered pairs, 5 ordered pairs, 2 or 1, up to you. We have question number 4 here, that if set M has 5 elements, then find the number of binary relation in M. This is very important this from examination point of view, because this type of questions can come in the multiple choice questions. So you have to pay attention here, that if set M has 5 elements, then find the number of binary relations in M. Here we are not going to find the number of elements in the Cartesian product, rather we are going to find the number of binary relations. So the number of binary relations can be found out with the help of formula given here. 2n, n stands for the number of elements, a into b. A into b is the Cartesian product. It means number of Cartesian product, number of elements in the Cartesian product. So here the number of elements in set M is given 5. Since this formula is concerned or connected with the Cartesian product, so if you are given 2 sets, so you are going to find the Cartesian product of those 2 sets. Whereas here just one set is given, so it means that M into M means Cartesian product of the same set M into M. So we are going to find the number of binary relations in the in M into M. So the number of binary relations can be found out with the help of formula. So here it will A into B means the Cartesian product of the 2 sets. Since here one set is given, set M is given, so M into M. If 2 sets would be given, so you can write A into B, or the name of the sets L into M, whatever it is. So the number of elements in set M is 5, and 5 into 5. It means if you will find the Cartesian product of a set M, so you will be having 25 elements in the Cartesian product. But the number of binary relations will not be 25. It can be found out with the help of formula 2 raised to the power means M into M. So if you will multiply 25 times, so you will be having 3,35,54,432 relations. You may wonder here that how. Of course, we can understand this, that suppose if you take this example. So from this Cartesian product, you can make many relations. Suppose you can just make A with A, then you can take A with B, then A with C, then A with AB with AC. So A alone means this ordered pair alone, this ordered pair alone. Then you can connect any ordered pair with any of the ordered pair, and you can make relation. So it's very difficult to estimate all the possible binary relations. So therefore mathematician has introduced this formula, or they have derived this formula to find the number of binary relations, because many relations can be made. Fine. Question number 5 is here that if set L has the elements x, this is given in set builder notation x, such that x belongs to natural number and x is less than and equal to 5. So first of all, let's make the set that means x, all the elements of the set belongs to natural number, and x is less than 5. Less than 5 are 4, 3, 2 and 1, and 5 is also included. So set L consists of the elements 1, 2, 3, 4 and 5. Then we have set my such that y belongs to prime numbers. This P stands for prime numbers, and y is less than 10. Less than 10 means all the prime numbers less than 10 can be 2 is the smallest prime number, then 3, then 5, 7. Remember that 1 and 9 should not be included in this set of prime numbers. Fine. Because 1 has 1 factor and 9 has 3 factors, and prime numbers are those numbers which have 2 factors. So 2, 3, 5 and 7 are the prime numbers. This question is also important from the examination point of view, so you have to pay attention here. Now we are going to make the relation from L to M. Here now you can observe that the relation is given. The identification, or the means it is given that what type of relation you are going to make. Fine. So first of all, we have to find the Cartesian product of both the sets. 1 with 2, 1 with 3, 1 with 5, 1 with 7, 2 with 2, 2 with 3, 2 with 5, 2 with 7, then 3 with 2, 3 with 3, 3 with 5 and 3 with 7, 4 with 2, 4 with 3, 4 with 5 and 4 with 7, 5 with 2, 5 with 3, 5 with 5 and 5 with 7. So here we have 5 elements and here we have 4. So 5 4s are 20, means 20 ordered pairs you will be having in L into M. First relation that we are going to make, this is relation number 1 denoted by R1. The relation is XY, means we are going to take such ordered pairs where y is less than x. Its mouth is open toward x, it means x should be greater. So from the list of, or from the set of Cartesian product, you are going to find such relation between the elements where x is greater than y. So you can see here x is less, here x is less, x is less. So here we can see that here first element is of x and second element is of y. So here first element is greater, 3 is greater than 2, 4 is greater than 2, 4 is greater than 3. Then here we can say 5 is greater than 2 and 5 is greater than 3. So here we can see that the first element in every ordered pair is greater than y. So this is the first relation that we have met here, and this relation is the subset of the Cartesian product. And we have another part of the question that we have to find the domain and range as well. So the domain will be 3, 4 and 5, whereas the range will be 2 and 3. You can see here that 2 is in repetition. Similarly, 3 is also being repeated. So you are just going to write it once. Okay, relation 2 is that x and y, the relation should be such that y and x should be equal. So here this is again the Cartesian product of L cross M, and we are going to find such relation that y and x should be equal. So you're going to find such ordered pairs where you can see that x and y are equal. So 2 and 2, 3 and 3, and 5 and 5. So this is the second relation. You can find the dominant range yourself. Next relation is that x and y, the relation between x and y should be such that x plus y should be 6. That if you plus x and y, so it should be 6. So you're going to find such relation between the elements that if you add them, the result will be 6. So you can see 1 plus 2 3, 1 plus 3 4. So of course 1 plus 5 can be, and 4 plus 2 can be 6, and 3 plus 3 can be 6. So this is the third relation here. Last relation is at R4, x and y relation such that y minus x is equal to 2. Yes, here you have to be attentive. Y minus x, that if you subtract x from y, so the result should be 2. Fine. Y minus x means y value should be, means x should be subtracted from y. So, and the result should be 2. So here we can 1 minus 3. Which one is x? X is 1 and y is 3. So x should be subtracted from y, means 1. If you will subtract 1 from 3, so you will get 2. Similarly here 3 with 5. If you will subtract x, which is 3, from 5, so you will get 2. Similarly if you will subtract 5 from 7, so you will get 2. One thing here, let me tell you that 4 minus 2 will also give you 2. But here means x is what? 4 and y is 2. So if you subtract 4 means x from 2, so it will result in minus 2. So you are not going to write this one. You have to keep in mind the order that x should be subtracted from y. So here we are done with exercise 5.5 with till question number 4. Here is your assignments for today. Okay, you have to go with exercise 5.5 from question number 1 till question number 5 in your neat notebook. All the questions are solved here and explained, so you can take the help of this video for doing your homework. This is all for today. Have a nice day and stay blessed.